The universe is full of strange objects, and astronomers are far from having discovered everything. When you look at the stars from Earth, you have no idea of the diversity of stars that exist beyond our planet and our galaxy. And above all, you are far from imagining all the unusual objects that populate the universe, hundreds of light years away from you. There are many objects that have been theorized by astronomers, but whose physical existence has never been proven. No model, even the most advanced, can guess the extent of the mysteries of the universe, which we discover little by little. Dear traveler, good morning. Today we'll embark on a journey to the heart of the universe, in search of the largest stars, the strangest materials, the most unusual planets, and the most massive objects that exceed human understanding. But before leaving for a new adventure, think of liking the video and subscribing to the channel to not miss anything. Thank you, and have a nice trip. Have you ever wondered, while looking at the starry sky from Earth, how many stars there are in the universe? Like you, scientists have studied this question. Although we can see thousands of stars from Earth, they represent only a very small fraction of all the stars in the universe. Some stars are simply too far away to be seen. The observable universe would contain nearly 200 trillion stars. That is, 200,000 billion stars. How could we imagine such a quantity? There are more stars in the observable universe than grains of sand on Earth. Moreover, if we converted each star into a grain of sand, there would be enough to cover the Earth with a thickness of 10 centimeters, i.e. 4 inches. There are, in the totality of the seas, oceans, rivers, and lakes of our dear planet Earth, less drops of water than there are stars in our observable universe. And yet, the observable universe represents only a tiny drop of water in an immense cosmic ocean. The size of the entire universe could contain a volume of space 15 million times larger than that of the observable universe. Finding the largest star in the universe is therefore a bit like looking for a tiny needle in a huge haystack whose limits we do not know. Especially since astronomers cannot measure the diameter of stars with precision because they are gaseous bodies. The boundary of a star is therefore a bit blurry. How can we know where the void begins and where the star ends? The more massive the star, the more difficult it is to measure its limits clearly. In addition, some stars have a variable size. That said, some stars stand out from the others because they are much more massive. These are the stars we are going to explore. Are you ready for this journey in search of the biggest star? Immediate boarding towards the most famous star. Direction: the Sun. The Sun looks very massive from the Earth, but in reality it is a very ordinary star, neither very big nor very small, nor very bright. The Sun has a diameter of 1.4 million kilometers, or about 1 million miles. This measurement is approximate, because beyond what appears to us as the border of the Sun, its influence continues for tens of thousands of kilometers and miles. And the solar winds ejected by the Sun can even reach the confines of the solar system. The Sun remains a massive star, as you can see. We could fit 1 million Earth planets in it. It represents 99.9% of the total mass of our solar system. Before continuing this journey, in search of the largest star in the universe, some information. You should know that the more matter there is in a star, the brighter the star is. In other words, the more massive the star is, the more luminous it will be. The phenomenon that occurs is that of a chain reaction. The more matter the star contains, the hotter and thicker its core. The more the hydrogen atoms will crash against each other. In this way, they will produce helium and release energy, which gives the star its brightness and heat. We are now 8.6 light-years away from the Earth. You can see ahead of you the brightest star in our night sky, Sirius. The fifth closest star in the solar system, Sirius is 1.5 times wider and twice as heavy as the Sun. You can actually observe it from Earth without needing a telescope. We continue our journey towards the Orion constellation, where Betelgeuse is located, which is, like Sirius, one of the largest stars visible to the naked eye. Located 427 light-years from Earth, it is 700 times the size of our Sun. If we replaced our star with Betelgeuse, its surface would touch the asteroid belt between Mars and Jupiter. The explosion of Betelgeuse at the end of its life will be a great event predicted by astronomers in the next 10,000 years, because we will be able to observe a supernova at a safe enough distance, but close enough. The North Star is another remarkable star in the universe that is located 450 light-years away from us. Did you know that different stars have held the title of North Star over the millennia? Yes, the North Pole moves as the Earth spins like a top, so the North Star changes every 26,000 years. The current North Star is a supergiant that can be easily spotted in the night sky, at the end of the handle of the Little Dipper. It is 5 times heavier than our Sun, and 37 times larger. Let's continue our journey towards the constellation of Cassiopeia. 10 times larger than our Sun, the star Gamma Cassiopeia is the brightest star in this constellation. But you were certainly attracted by another star of yellow color. It is Rho Cassiopeiae, a yellow hypergiant located at 3,400 light-years from the Earth. Our galaxy has only a few dozen stars like this, 900 times larger than the Sun, and 300,000 times brighter. You can see it too in the night sky without a telescope. We are now 7,500 light-years away from Earth. The hypervariable giant that you have in front of your eyes is Eta Carinae A, a star that was noticed in the 19th century for its phenomenal explosions. It then expelled 10% of its mass, which today forms one of the largest known nebulae. It is 120 times the mass of the Sun, and 1,150 times its diameter. All the stars you have seen on this trip are impressive, but they are not the biggest stars we know. This title could go to the star Mu Cephei, also called the Garnet of Herschel, located at about 2,090 light-years from our Earth. This star is neither more nor less than the best-known red hypergiant. Its diameter is 2,000 times that of the Sun, it could contain 1 billion suns. At a little over 3,000 light-years from our Earth, the super-red giant VY Canis Majoris, which is part of the constellation of the Great Dog, could it also claim the title of largest known star. It could contain 3 billion suns, even if it weighs only 17 times the weight of our star. Its diameter is 1,500 times that of the Sun. Its explosion is expected within the next 100,000 years, and it could well destroy part of the neighboring star system that surrounds it. We are too far away for it to have an impact on the Earth. UY Scuti has also long been considered the largest star currently known. Its diameter has been estimated at 1,700 times that of the Sun, but this measurement is imprecise. In 2012, the star was thought to be located 9,000 light-years from Earth. But in 2018, an ESA astronomy mission estimated that it was actually only 5,000 light-years away. UY Scuti would then be smaller than previously thought, still measuring about 2.4 billion kilometers, or 1.5 billion miles wide, or 16 times the distance between the Earth and the Sun. In the top 4 of the largest known stars, we also find Stephenson 218, a red supergiant 2,150 times larger than the Sun. It would take 10 billion suns to fill it. This star is very distant, since it is estimated to be 20,000 light-years from Earth. Although this star is the largest star currently discovered, this does not mean that it is the largest star in the universe. And to tell you the truth, we are not yet out of our galaxy, the Milky Way. The ranking has not finished changing. As you have understood, the top of the ranking is still occupied by red, hyper-sized stars. They are not the most massive stars, nor the hottest, nor the most luminous, but they are the ones with the most voluminous envelopes. When they collapse, they give birth to a Type II supernova. According to astronomers, there are no red hypergiants larger than 1,500 solar diameters, because beyond that, their upper layers would break up. Now that you have been able to observe the largest stars we know, we continue our journey in search of the unusual objects hidden in the universe. The star PSR JO 952-0607 is amazing because it is the most massive neutron star ever observed. According to the researchers, it would even be at the limit of the maximum mass for a neutron star before it changes into a black hole. It is also the fastest star in the Milky Way, since it makes 707 revolutions on itself per second. Nicknamed Black Widow, in reference to the female spiders that devour the male after mating, the star spins so fast that it takes matter away from the companion star that evolves next to it. The star close to PSR J0952-0607 has been almost completely devoured. It is now only 2% the mass of the Sun. Let's continue our journey towards the most unusual objects in the universe. We will witness an impressive phenomenon, the death of a star. When they are at the end of their life, the most massive stars, that is to say, those which are 10 times the mass of the Sun, die in an explosion which is caused by the collapse of their heart. This is called a supernova. The supernova is a fascinating phenomenon. When the core of a supergiant is no longer able to produce energy by nuclear reactions, it will transform its gravitational energy and create energy by contraction. The matter of the core becomes neutrons, and it becomes very rigid. When the outer layers of the star collapse, they crash into the rigid, incomprehensible core, creating a monumental shockwave. The explosion will blow the envelope of the star and eject its matter through space at several thousand kilometers per second. The dead star will then become a neutron star, or a black hole, depending on its mass. The supernova can shine up to 10 billion times brighter than the Sun. That is to say, as much as a galaxy. But that's not all. The shock waves generated release material into the interstellar medium that can be used to create new stars. Fascinating, isn't it? In the history of humanity, some supernovae have remained in the collective memory. The Chinese were the first to observe and describe supernovae. In 1054, a supernova in the Taurus constellation remained visible for 3 weeks in daylight. Today, at the very location of this supernova, we can observe the Crab Nebula, consisting of the remains of the envelope of the dead star. Tycho Brahe in 1572 and Johann Kepler in 1604 were the first to officially observe supernovae in the West, at a time when the heavens were thought to be immutable, as described by Aristotle. The supernova you witnessed on this trip was caused by the collapse of a massive star. It is a Type II supernova. But then, there are other types of supernovae? A supernova can also be created by the explosion of a white dwarf, a very dense star that is actually the remnant of a dead star. White dwarfs are formed when a medium-sized star reaches the end of its life. Our Sun, which is considered a medium-mass star, will turn into a white dwarf at the end of its life. Rest assured, this will not happen for another 5 billion years. When a white dwarf is located next to a giant star, the latter will lose its outer layers, which will form a disk around the white dwarf. Little by little, the white dwarf will gain in mass, until it exceeds the limit, called the Chandrasekhar limit. It will then collapse, catch fire, and disintegrate. This explosion is a Type I supernova. Type I and Type II supernovae are very similar to the eyes of a distant observer like you. Let's continue our journey to the most unusual objects in the universe. The universe still holds many secrets and objects that are beyond human comprehension. What you see before you is a pulsar star. Do you think it looks like a gigantic nucleus of atoms? In reality, it is a very compact star, its mass being of the order of that of our Sun, for only about 10 kilometers in diameter. These are what you can call the corpses of stars. Yes, before they were pulsars, they were very massive neutron stars that died by producing a supernova. Neutron stars are also fascinating stars that defy all laws of physics. These stars have an extreme density, gravitational field, and magnetic field. The collision of two neutron stars is something spectacular. It produces impressive gravitational waves and gives birth to kilinovae, the supernovae of neutron stars. Pulsars have been an important discovery in astronomy. The existence of neutron stars had been predicted as early as 1933 by two astronomers, the German Walter Body and the Swiss Fritz Zwicky, and it is the discovery of pulsars that has confirmed their existence. Pulsars have the particularity of emitting radio waves at a fast and regular rate. They are of great interest to radio astronomers. It is these radio waves that allowed the discovery of pulsar stars. In 1967, Jocelyn Bell and Anthony Hewish were studying the propagation of radio waves in the interplanetary medium when they discovered, by chance, a source of very regular radio pulses. It was the pulsar PSR 1919 plus 21, 2,000 light-years from the Sun, in the constellation of Little Fox. Radio astronomers have studied this phenomenon and have not been slow to discover many other sources of similar pulses. The pulsar star emits very fast pulses, with a period of between a few milliseconds and a few seconds, and very regular. Moreover, the pulsar is so amazing that we first thought that it was an extraterrestrial signal. In addition to that, its rotation is very fast, of the order of 1 second. A normal star could not rotate so fast, because the centrifugal force produced would break it up. The pulsar star can do this because it is very small and very compact. The pulsar that you can now observe is the most famous. It is the pulsar of the Sales, or pulsar of Vela, located, as you guessed, in the constellation of the Sales, 959 light-years away from Earth. Its scientific name is PSR B0833-45. This young pulsar was discovered in 1968. We have been following it for more than 50 years. It is one of the most studied objects in the universe. Are you ready to discover the brightest objects in the universe? Even brighter than the stars? Let's go! Quasars are fascinating objects. They are supermassive black holes with an extremely luminous region in the center. The quasar needs 1,000 stars with a mass at least equal to that of the Sun to remain active. Otherwise, it dies. Quasars were very common at the beginning of the universe, but they are increasingly rare. There is now one every 1,000 galaxies. You are probably wondering why. Quasars feed on absorbable matter. After the Big Bang, there were many of them. But by absorbing everything, quasars have not found any more matter to feed on, which explains why many have disappeared. As you have seen, quasars are very bright. When you look at them through a telescope, you can see them as very bright stars, even though they are millions of light-years away. This is not surprising when we know that quasars are 5 million times brighter than the Sun. So why are they called quasars? This is an old story. In 1963, a paper by Dutch astronomer Maarten Schmidt and his colleague John Beverly Oak, published in the journal Nature, turned the world of astronomy upside down. These two astronomers had just discovered singular stars, which they called quasi-stellar radio sources. In 1964, the astrophysicist Hong-Yi Chu proposed the name of quasar. When the existence of quasars was discovered, it was not long before they were mistaken for a star. A quasar looks like a very bright star. One difference put astronomers on the track. The spectrum of the first observed quasar, quasar 3C273, was streaked with bright spectral lines and not with dark lines like the spectrum of a star. As the spectral lines are the signature of atoms, we could conclude that they were not the same atoms as in a star. So yes, it was not a very bright star, but of what? In addition, by analyzing the spectrum lines of the mysterious object, the astronomers concluded that it must be even more distant than all the galaxies known until now. It was indeed a new object in the universe, never observed before, very distant and extremely bright. Yes, 3C273 was 2.4 billion light-years away from our galaxy, and yet it could be observed. Incredible! To give you an idea, the size of our galaxy is only 100,000 light-years. What is impressive about this quasar story is that astronomers were able to measure how different the universe had been in the past. According to the Big Bang Theory, the more distant objects are observed, the further back in time we go. Hence, the astronomical unit in light-years. 1 light-year represents the distance traveled by light in 1 year. Thus, the light of our sun takes 8 minutes to reach the Earth. We see our sun as it was 8 minutes ago. The star Sirius, which we visited before, is more than 8 light-years away from the Earth. If you look up at the starry sky to see it, you see it as it was 8 years ago. But the quasars, you can see, reflect part of the cosmos as it was billions of years ago. It is very likely that some of the bright stars that you can see shining during starry nights from Earth no longer exist today. To return to quasars, they are not found near our galaxy, so they are witnesses of the universe as it was several billion years ago, and whose appearance was totally different from ours. Quasars are truly fascinating objects. In fact, the most massive object in the universe, according to astronomers, is a cluster of active quasars, powered by huge black holes, and stretching over 4 billion light-years. You're not done being impressed by the stars. Hang on, we're continuing this journey to the constellation Cygnus, about 1,470 light-years from Earth, where there is a yellow-white star named KIC 8462852. It is also called Tabby star, which is easier to remember. This star does not look very impressive. Its mass is 1.4 times that of the Sun, and it is not even visible to the naked eye. Yet it fascinates astronomers because it shows very unusual variations in brightness. For over 100 years, decreases in brightness of up to 22% have been recorded, sometimes for several days. It is as if there was a celestial body that passed irregularly in front of the star, except that the explanation is not there. There is neither star nor planet passing in front of Tabby's star. Especially since scientists have estimated that if a planet the size of Jupiter passed in front of Tabby's star, the variation in brightness would be only 1%, and it would be periodic. Here, we have a thorny problem. The brightness of Tabby's star varies aperiodically with an unprecedented amplitude, and this for a century. Astronomers have been looking for explanations for this phenomenon, and are still investigating the causes of this behavior. The light variations of Tabby's star could be explained by the presence of a dust ring around the star, by fragments of large comets, by disturbances on the surface of the star, or by a technical problem of the observation satellite. The problem is that all these hypotheses have been verified and rejected. Astronomers claim that the characteristics of Tabby's star make such fluctuations impossible. The star belongs to the main sequence, the area where most observable stars are found, and it is of spectral class F3, which means that it is a little bigger and a little hotter than our Sun. Its luminosity should then be stable and not change for several tens of millions of years. But then where do these mysterious fluctuations come from? But there could be another explanation. It is that the variations of luminosity are artificial and caused by the activities of an advanced extraterrestrial civilization. For example, a very technologically advanced civilization could have built a Dyson sphere around its star. The Dyson sphere is a structure that captures much or most of the light energy emitted by the Sun. To verify this hypothesis, the SETI Institute spied radio and laser emissions from Tabby's star. No emissions were detected, but only very powerful emissions directed towards us could have been. For the moment, no real conclusion can be drawn about the existence or not of an ultra-advanced extraterrestrial civilization in the constellation of the Swan, especially since the history of astronomy teaches us that every time we thought we had found a phenomenon due to the activity of an extraterrestrial civilization, we were wrong. Who knows? Maybe the discovery of a new stellar object? We're not done with amazing stars. In September 2018, astronomers discovered a neutron star 800 light-years from Earth through the Hubble Space Telescope that emits a very intense infrared light stream. Normally, neutron stars emit radio waves, but this one has decided otherwise. It is the only star that emits a signal only in the form of infrared light, and in a prolonged way. According to NASA, two hypotheses can explain this strange phenomenon. The first possible explanation is a dust disk surrounding the neutron star. The dust disk would be a remnant of the supernova, because, as you saw a little earlier, the neutron star is formed following the death of a star. This disk would be composed of material from the massive star that exploded. We speak of folding disk of the supernova. This hypothesis, if confirmed, will totally change our understanding of the evolution of neutron stars. The other possible explanation is an energetic wind that emanates from the neutron star and is transformed into gas when it comes into contact with space. The infrared emission would then be a pulsar wind nebula. The pulsar wind is produced when a neutron star with a strong magnetic field rotates rapidly. If the neutron star is moving at a speed greater than the speed of sound, a shock can be formed at the point of intersection of the pulsar wind and the interstellar medium. The radiation from the collided particles would be the observed infrared radiation. Usually, pulsar wind nebulae are observed with X-rays. An infrared pulsar wind nebula would be very unusual. This has never been observed. Astronomers should observe this phenomenon with the James Webb Telescope, which is designed for infrared as opposed to the Hubble Telescope, which is more focused on ultraviolet and visible light. We may then know more. You have understood that stars are giant balls of hot gas which constantly consume energy, like an engine burning hydrogen, and which emit a lot of heat. However, there are stars in the universe that are cooler than others. The record holder of the coldest star is WD 0806-661b, a brown dwarf with an estimated surface temperature between 27 and 80 degrees Celsius, or between 80 and 176 degrees Fahrenheit. Temperatures very close to those observed on Earth. The second coldest star is CFB-DS IR, 1458 plus 10b, a brown dwarf with an atmospheric temperature of 100 degrees Celsius or 212 degrees Fahrenheit, the temperature of boiling water. For comparison, the temperature of the Sun is 15 million degrees Celsius or 27 million degrees Fahrenheit at its core and 6,000 degrees Celsius or 10,800 degrees Fahrenheit at its surface. Brown dwarfs are bodies that are too small to be considered as stars, but that form in the same way. These two stars are at the limit between a small cold star and a large hot planet. They belong, in fact, to the category of ultra-cold dwarfs, whose temperature is lower than 2,400 degrees Celsius or 4,300 degrees Fahrenheit. WD 0806-661b is located 63 light-years from Earth, in the constellation of Pisces. Its mass is 6 to 9 times less than that of Jupiter. It is part of a binary system with a white dwarf, WD 0806-661a, but the two dwarfs are spaced 2,500 astronomical units apart, that is to say, 2,500 times the distance between Earth and the Sun. In the universe, other objects have been identified by the Spitzer telescope and seem qualified to be among the coolest stars in the universe. But as their temperature has not yet been measured, we do not know more yet. We continue this journey to the most unusual objects in the universe with the strongest material in the universe, which scientists have dubbed nuclear pasta. You won't be surprised, after traveling to the heart of the most impressive stars in the universe, to know that this material is found in stars. Nuclear pasta is a hypothetical material that would be found in the crust of neutron stars, those very compact stars, or in the core of a core collapse supernova. It would be degenerate matter, very dense, with a density of 1,014 grams per cubic centimeter. For reference, the inner core of the Earth has a density of about 13 grams per cubic centimeter. Osmium metal, the densest material on Earth, has a density of 22.48 grams per cubic centimeter. To break nuclear pasta, it would take 10 billion times the force needed to break steel. Why are we talking about nuclear pasta? Astronomers name this material after its shape. Yes, the material would look like pasta, including lasagna and spaghetti. Even if this material remains hypothetical, if its existence is verified, it could help astronomers to better understand the mechanisms of gravitational waves that have been detected following a collision between two neutron stars. We now return closer to Earth to observe a dwarf planet of our solar system, which has always intrigued astronomers since its discovery in 2004, Haumea. This planet orbits in the Kuiper Belt, beyond Neptune, at more than 8 billion kilometers from the Sun, that is to say, more than 5 billion miles from the Sun. Our solar system contains 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. In addition to these 8 planets, there are also 5 dwarf planets: Pluto, Ceres, Eris, Makemake, and Haumea. The dwarf planet Haumea, named after a Hawaiian goddess, surprises astronomers because it is oval, unlike all the other planets in our solar system, which are spherical. It looks like a giant rugby ball, 2,322 kilometers long, or 1,442 miles long. Like Saturn, it has a ring, which was later discovered in 2017. A surprising observation for scientists who previously thought that only giant planets had rings. This ring is very dense and compact, like the rings of Saturn, It measures 70 kilometers or 40 miles wide, with a radius of 2,287 kilometers or 1,400 miles. It is, according to astronomers, the result of a collision with another body in the distant past. The impact that created the ring around the dwarf planet would also likely have created its two moons, Hyakka and Namaka, and a cloud of debris clustered in the ring. Haumea is one of the fastest bodies in our solar system, since it completes a full rotation in less than 4 hours. This is certainly the explanation for its elongated shape. It spins so fast that it has elongated as it spins. Astronomers have studied this amazing little planet. It will be composed mainly of ice, but also of rock. This observation has once again shaken up the belief of scientists. Until then, it was thought that the rings could only form if the ice was friable, because it was close to the sun. Haumea demonstrates the opposite, with very dense ice. As you can see, the discovery of Haumea has raised many questions from scientists and challenged many ideas. Rings have recently been observed around other dwarf planets, including Chariklo and Chiron, which are located between Saturn and Uranus. Let's move away from the Earth to observe another unusual planet in the universe, the wandering planet, SIMP J01365663. This planet is located in the Pisces constellation, about 20 light-years from Earth. It would be 200 million years old, and it is about 12 times bigger and more massive than Jupiter. Astronomers call it a wandering planet because it does not orbit directly around a star. This planet has certainly been thrown away from its star by gravitational forces. What makes SIMP strange is not only the fact that it is a stray planet, because there are others in the universe. It is also surprising because it has a magnetic field 200 times stronger than that of Jupiter. As a result, its atmosphere is charged with electricity, and auroras can be observed there permanently. This planet was discovered in 2016 by the Very Large Array, a radio telescope in New Mexico. It was initially mistaken for a brown dwarf, those so-called failed stars that are not massive enough to shine like a star, but too massive to remain in the category of gas giants, like Jupiter and Saturn. But more recent observations have shown that it is in fact a planet. This unusual object is at the border between a brown dwarf and a planet. That's right, the boundary is 13 times the mass of Jupiter, while this planet is 12.7 times the mass of Jupiter. Beyond 13 times the mass of Jupiter, the pressure is sufficient to cause the fusion of deuterium. On the other hand, its gravity does not cause hydrogen fusion, as it is the case for stars in general like our Sun. What about the magnetic field? You wonder how to explain it? Astronomers have proposed a theory through a study published in the Astrophysical Journal. It could be due to interactions between the planet and one or more moons. SIMP is a fascinating object, and it is not an isolated case. Astronomers are discovering more and more objects, planets or stars, that seem lost in space. For example, bodies the size of Jupiter have been discovered between 10,000 and 20,000 light-years from Earth, which do not belong to any star system. Again, these could be planets that have been expelled from their system. In any case, astronomers have understood that we will be able to detect other elusive planets because they are lost in space, without any parent star, in the same way that we have detected the existence of SIMP, thanks to auroral radio emissions. As you could see earlier, When we were observing Haumea, the oval planet, the 8 planets of our solar system all have a different color. Our Earth appears blue from space. The planet Mercury is rather gray, because it is a rocky planet, composed mainly of iron, nickel, and silicates. Venus, difficult to observe because of a dense layer of sulfuric acid clouds, appears yellow. Mars is known as the red planet because of the iron oxide present on its surface. Jupiter has several colors: orange, brown, and white. These colors are changing and vary depending on the exposure of the clouds surrounding Jupiter to ultraviolet light. Saturn looks a bit like Jupiter, with pale gold and white bands. Uranus has a cyan blue color because it is composed mainly of molecular hydrogen and helium. Neptune looks like Uranus, but with a darker blue color. Somewhere in the universe, we can observe a strange planet with a completely black color. It is an exoplanet named TRES-2b, located in the Dragon constellation, more than 750 light-years from Earth. It is the darkest planet ever discovered, simply because it reflects less than 1% of the light that hits it. Thus, its reflectivity is even lower than that of black acrylic paint. TRES-2b was first discovered on August 21, 2006, and its characteristics were studied in 2008. As you can see, it is quite large. Its radius and mass are just slightly larger than those of Jupiter. You're probably wondering why this planet is so dark? Astronomers have not really been able to explain this phenomenon completely, but some theories exist. This dark surface could be explained in part only by a gas that would form the mass of the planet and would absorb almost all the light. For example, the presence of titanium oxide, sodium, or potassium in the atmosphere could explain this black color. TRES-2b is certainly the closest object in the universe to the image we have of hell. You can see that it shines with a faint red glow, a bit like a burning coal. At its surface, the temperature is 1100 degrees Celsius, or more than 2012 degrees Fahrenheit. Let's go now to 40 light-years from the Sun, in the constellation of Cancer. Direction: 55 Cancri E, an exoplanet which has several particularities. First, it is the closest planet to its star known to date. It is 60 times closer to its star than we are to the Sun. It is therefore in orbit around its star 55 Cancri A, or Rho Cancri, which is a yellow dwarf. But this is not the only unusual feature of this exoplanet. 55 Cancri E is a carbon planet, which means that instead of being composed of silicate rocks and metals like the Earth, Mercury, or Venus, it is composed only of carbonate compounds. Its mantle and crust are made of silicon carbide, graphite, or diamond. Yes, diamond is in fact like a pencil lead, but very dense. 1/3 of the planet 55 Cancri E is diamond, while it is 8 times more massive than the Earth and 2 times larger. It has not yet been possible to verify that this planet is indeed a diamond planet. Astronomers were able to measure its mass and radius when it was in transit in front of its star, and from these data and numerical models, they deduced its composition. The most recent findings confirm that there is no water on 55 Cancri E, but carbon compounds. In any case, we know that 55 Cancri E cannot harbor life, not only because it is extremely hot, but also because it rotates at a very high speed around its sun, 55 Cancri A. On this planet, a year is not 365 days, but only 18 days. Let's continue our journey in search of the most unusual objects in the universe towards two planets that have been in the news because they could harbor life. Astronomers are constantly looking for planets with properties similar to those of the Earth, which could host an extraterrestrial civilization. Just like Earth, two planets seem to have the ideal conditions for the birth of life. Let's start with Kepler 438b. This exoplanet, discovered in January 2015, is located about 475 light-years from the Sun, in the constellation Lyra. It owes its name to the Kepler telescope, thanks to which it was discovered. It is the closest exoplanet to Earth ever discovered to date. Astronomers have developed an index of similarity with the Earth. The closer the index is to 1, the more similar the planet is to Earth, and the closer the index is to 0, the further away the planet is. Kepler 438b obtained the score of 0.88, which is not nothing. This index is a good indicator. However, it is far from being sufficient to determine whether or not an exoplanet is a good candidate to replace the Earth. Let's take the example of Mars. The red planet seems today to be the most favorable for the development of life among all those which make up the solar system. Its similarity index with the Earth is 0.815. This is less than that of Venus, whose index is evaluated at 0.979. Yes, Venus is more similar to Earth than Mars, according to this tool. On the other hand, its thick atmosphere is very rich in greenhouse gases. Thus, the average temperature at the surface of the Shepherd star is 462 degrees Celsius, or 860 degrees Fahrenheit. In view of these data, our twin appears much more hostile. This is why researchers cannot rely solely on the TSI to select potentially habitable planets. But let's come back to Kepler 438b. This exoplanet is not located anywhere around its star. Indeed, it is what is called a Goldilocks planet. This means that it is in the habitable zone of its star. It is neither too close nor too far away, like the Earth. This is important because if it were too close, it would be too hot, and if it were too far away, it would be too cold. Moreover, Kepler 438b could contain water in liquid form, which is essential for life. 12 times larger than the Earth, it is likely to be a telluric planet and not a gaseous one, like Jupiter and Saturn. This planet is promising, but a recent study has raised some concerns. First, its complete revolution around its sun is done in only 35 days. And then, the planet receives 40% more light radiation than the Earth, because its star is a red dwarf, and not a yellow dwarf like our sun. Its star is also capable of powerful coronal mass ejections, phenomena that are triggered on the surface of a star, and can create, in contact with a magnetic field, magnetic storms. These coronal mass ejections release as much energy as 100 billion megatons of TNT, and they occur every few hundred days. If Kepler 438b does not have an atmosphere like the Earth, it would be particularly vulnerable to these phenomena, which would make it a hostile environment for the development of life. Another planet has aroused the hope of astronomers in search of another source of life in the universe. Gliese 581c is a telluric exoplanet, located about 20.5 light-years from Earth. Like Kepler 438b, it is located in the habitable zone of its star, Gliese 581. Unlike Kepler 438b, its star is particularly stable, even if it is also a red dwarf and violent eruptions remain possible. This means that the variations of luminosity remain minimal and would not produce too extreme temperature changes. Gliese 581c could therefore host life, but also its evolution. However, the game is not won in advance. Venus and Earth do not have much difference in size, and they are both located at comparable distances from the Sun, and yet Venus does not host life. Gliese 581c could be an ocean planet. Astronomers think that it is in synchronous rotation with its star, which would mean that it always presents the same face to the Sun. Life could therefore have developed there, but only in the middle, between the hot part always facing its star and the cold part always in the dark. It is this small band that would be habitable. If Gliese 581c hosts life, it would be very different from life on Earth. Because its sun is red, the sky would not be blue, but crimson. The planets would not be green, but black. Astronomers sent a radio signal to Gliese 581c on October 9, 2008. Because the planet is located 20.5 light-years from Earth, it will not arrive until the spring of 2029. And if there is an answer, it will not reach us before the fall of 2049. Let's continue our journey to the exoplanet WASP-12b, located 870 light-years from Earth, in the constellation of the Coachman. This planet has an amazing feature. It is being nibbled by its star. WASP-12b is so close to its star, WASP-12, that its temperature is very high. On top of that, it absorbs more than 94% of the incident light, according to astronomers' studies. Result: it loses 6 billion metric tons per second. It is not even spherical anymore. It spins so fast on itself, and the gravitational force is so high that it is stretched by the tidal forces of the star. It now looks like a rugby ball, like the planet Haumea that you observed earlier. Although it has 40% more mass than Jupiter, astronomers predict that at this rate it will be completely sucked up by its star in about 10 million years. We are now traveling to PSR B1620-26b, which is none other than the oldest planet in the universe. Yes, this planet is more than 13 billion years old, according to astronomers' estimates. It was born only 1 billion years after the Big Bang. This is why this planet is called Methuselah. This planet was discovered in 1993 and is located more than 12,400 light-years from Earth in the globular cluster M4 in the Scorpio constellation. It is made up only of primordial elements, such as hydrogen and helium, because at the time it was formed, elements such as iron did not yet exist. It orbits two stars, a pulsar of 1.35 times the mass of the Sun, and a white dwarf of about 0.34 times the mass of the Sun. Astronomers have developed a theory to explain the formation of this planet 13 billion years ago. It could have been formed at the same time as the other stars of the globular cluster M4. It may have been part of a planetary system that has since been captured by a neutron star. This neutron star could be the current pulsar, and its parent star, the current white dwarf. Impressive, no? Stars and planets are not the only objects in the universe to amaze the scientific community. Fasten your seatbelt. We are going to discover the largest galaxy in the universe, You might get dizzy. Our universe is so immense that our human brain has difficulty to get an idea of it. Our solar system already seems infinite, with huge objects like the giant planet Jupiter, whose diameter is 10 times that of our Earth, and the Sun, whose diameter is 110 times that of the Earth. And still, as I told you at the beginning of our journey, the Sun remains a banal star, still very small compared to the red giants which are everywhere in space. Black holes and supermassive black holes are even bigger than the biggest stars you could see at the beginning of this trip. For example, the M87 black hole has a mass of 6.5 billion times the Sun, and a diameter of 38 billion kilometers, or 23 billion miles. The record is held by the black hole Holm 15A, located in the galaxy Holmberg 15A, whose mass is equivalent to 40 billion times the Sun. There are also particularly immense galaxies. Our galaxy, the Milky Way, extends over 100,000 light-years. Imagine how infinite this distance already seems to our brain. It can contain between 200 and 400 billion stars, and as many billions of planets, but is far from being the largest galaxy. The largest known galaxy in our universe is the Alcyone galaxy. The Alcyone galaxy is considered as the largest galaxy of our universe only since February 2022. Before that, the title has long been attributed to the galaxy IC 1101, whose diameter is still 3.9 million light-years. IC 1101 is an E3 type galaxy, that is to say, an elliptical galaxy. It is located 1 billion light-years from Earth, in the constellation of the Serpent. Its numbers are mind-boggling, with a mass 2,000 times greater than that of the Milky Way. It would house more than 100,000 billion stars. This may seem staggering to you, but the Alcyone galaxy does even better. This radio galaxy, located 3.5 billion light-years from Earth in the Lynx constellation, extends over a length of 16 million light-years. It is, according to the astronomers who discovered it, the largest structure of galactic origin. You'll be amazed, there are objects even larger than this huge galaxy. The Great Wall of Hercules' Boreal Crown is the most massive structure in the observable universe, with a diameter of 10 billion light-years. It is a galactic filament, that is to say, a structure composed of galaxies and clusters of galaxies, linked together by the gravitational force. You are now going to discover a galaxy like no other. Theoretically, 80% of the total mass of the universe is dark matter. That's in theory, because researchers have identified a galaxy that seems to be completely devoid of dark matter. It is the galaxy NGC 1052 DF2. It is located about 62 million light-years from Earth in the Whale constellation. Or rather would be, because its existence has not yet been confirmed, which is normal given the distance. Dark matter is not visible. If astronomers have been able to identify it, it is because it affects ordinary matter due to its gravitational force. But NGC 1052 DF2 seems to have no dark matter, only ordinary matter, while a galaxy of this type should have 100 times more dark matter than ordinary matter. Astronomers reached this conclusion by examining the galaxy with optical lenses and tracking the motion of 10 star clusters to determine the amount of mass present in the galaxy. Surprisingly, the mass of the galaxy is about the same as that of a star. the discovery calls into question the way we thought galaxies were formed. Astronomers used to think that dark matter was essential to the process of galaxy formation. Speaking of unusual galaxies, there is also DGSAT-1, a galaxy that intrigues astronomers. This ultra-diffuse galaxy is completely isolated. Let me explain. Normally, ultra-diffuse galaxies, whose size is comparable to that of the Milky Way, form a cluster. But DGSAT-1 is alone in its region. Moreover, it shines only with a very weak starlight. Its stars are very difficult to observe, even with a powerful telescope. To top it all off, it contains very little iron, although its magnesium content is normal. This is surprising for astronomers because supernovas release iron and magnesium. Where there are stars, there should be a lot of iron. Astronomers have no idea how this galaxy, which is called a fossil galaxy, was formed. It is known that it has changed very little since its birth, because it is not like other ultra-diffuse galaxies, upset by galactic collisions. Astronomers believe that it took a long time to form. It would have started to form at the beginning of the universe, and would have continued until only 3 billion years ago. This phantom galaxy could be a living fossil from the dawn of the universe, when stars and galaxies emerged. The universe was then very different from the one we observe today. Because it is isolated, this galaxy would not have undergone any collision that could have changed its appearance or composition since its formation tens of billions of years ago. Our journey is coming to an end. We have one last unusual object to explore: the vacuum. We have explored many objects in the universe: giant and remarkable stars, supernovae, amazing planets, and gigantic galaxies. We've even taken a look at black holes, those fascinating ultra-compact objects that create a gravitational field so intense that they suck in all the light. But we haven't found a vacuum in space yet. Astronomers, however, have found one. Yes, as strange as it may seem, there is a vacuum in the universe. And the vacuum that we are going to talk about has a name: the KBC vacuum, or local hole. This vacuum is about 2 billion light-years wide. This is equivalent to 1.9% of the diameter of the observable universe. You think that this vacuum, in addition to being very dark, is located far from us? Well, in fact, as for the other voids, it is not completely empty, but contains the Milky Way, the local group, and most of the Laniakea supercluster. The Milky Way is located a few hundred million light-years from the center of the void. Astronomers have taken on the difficult task of figuring out how this void was formed. Not enough billions of years have passed for this area to have been cleaned, or emptied if you prefer, by gravitational forces. The only theory that makes sense is the merging of several smaller voids, in the same way that soap bubbles merge to form larger ones. Whether the existence of the KBC vacuum is compatible with the Lambda CDM model is debated. As a reminder, the Lambda cold dark matter, or Lambda CDM model, is a parameterization of the cosmological Big Bang model, in which the universe contains 3 major components. First, a cosmological constant, noted lambda associated with dark energy. Second, the postulated cold dark matter, abbreviated CDM. And third, ordinary matter. It is often called the standard model of Big Bang cosmology because it is the simplest model that accounts reasonably well for the following 4 properties of the cosmos: the existence and structure of the cosmic microwave background, the large-scale structure and the distribution of galaxies, the observable abundances of hydrogen, including deuterium, helium, and lithium, and finally, the acceleration of the expansion of the universe, observed in the light of distant galaxies and supernovas. While some say that voids as large as the KBC vacuum are inconsistent with the Standard Model, others argue that the existence of supervoids, such as the KBC vacuum, is consistent with the Standard Model. Galaxies within a vacuum experience gravitational attraction from outside the vacuum, resulting in a larger local value for the Hubble constant, which is a cosmological measure of the expansion rate of the universe. Thus, people inside this vacuum would have the impression that the expansion speed of the universe is greater than if we were outside this vacuum. In any case, this means that we are in an empty part of the universe. And yet, as you have seen, there is plenty of material to discover, each more impressive than the last. Dear space traveler, our excursion is now over. This journey through the mysteries of the universe will have allowed you to discover a tiny part of all that is hidden in the infinite space.